Hey guys, welcome to Math for Kids by a Kid. Today we're going to learn about the real number system. The real number system includes a whole bunch of types of numbers, all of which are listed here. So as you can see, the different types of numbers are natural numbers, whole numbers, integers, rational numbers, and irrational numbers. And we're going to look at examples of each of these types of numbers. Let's start with natural numbers. Natural numbers are counting numbers. In other words, they're positive integers. So 1, 2, 3, 4, 5, and etc. So 6, 7, 8, and you can go on forever, as long as the numbers are positive integers. Now let's look at whole numbers. Whole numbers are all the natural numbers plus 0. So like I showed you before, I showed you some examples of natural numbers. So 1, 2, 3, 4, 5, and it's the same thing here, except you just have a 0 included, and everything else in the set of whole numbers is the same as natural numbers. So 0, 1, 2, 3, 4, 5, and etc. Now let's look at integers. Integers are whole numbers and negative counting numbers. Negative counting numbers are basically the same as positive counting numbers, except they're negative. So negative counting numbers are -1, -2, -3, -4, and etc., as long as there's no decimals. And then, of course, the integer set includes the numbers that I mentioned before, 0, 1, 2, 3, 4, and so on. Rational numbers can be written as a fraction in the form a over b, where a and b are both integers, and b is not 0. So b is any number but 0, because you can't divide a number by 0. That's impossible. Rational numbers can also be expressed in the form of a decimal on two conditions, either of two conditions. One is that it ends, or two, that it has a repeating pattern. And I'll show you what I mean down below. Take 0.25, for example. This is a rational number because it ends. It ends at this 5 here. Now let's look at this decimal. 0.251437, and it just goes on forever with these random types of numbers, and it never ends. This is not a rational number. This is an irrational number, which we'll talk about in a little bit. But the point is that if a rational number is in the form of a decimal, it either has to end, like 0.25, or it has to have a repeating pattern like this. 0.33 repeated. The line on top of the 3 shows that that number is repeated forever. So this really is 0.3333 forever. This is a rational number because there's a number that repeats. Let's look at another example. 0.816 repeated. I'm going to put a line on top of all three numbers because this really means 0.816, 816, 816 forever. This is a rational number because there are three numbers that are repeating forever. So if a decimal has a repeating pattern, that means there's either one number that repeats on forever and ever, like 0.33 here, or there's a set of numbers that repeats in the decimal, like 0.816. All perfect squares and all perfect cubes are rational numbers because if you have a perfect square, you'll get a natural number as a result. So, example, square root of 25. The answer is 5, and 5 is a natural number. And if you cube root a perfect cube, like cube root of 64, you get 4, and that's also a natural number. And you can even cube root a negative number, so cube root of negative 27, and you get negative 3, which is an integer. So perfect squares and perfect cubes are all rational numbers. A rule is that you cannot square root a negative number. You can cube root a negative number. And lastly, we get to irrational numbers. Irrational numbers cannot be written as a fraction in the form a over b. The decimal form of an irrational number does not end and does not repeat. So it's like the example I showed you above, where there's that decimal that just kept repeating on with random numbers and never ended. A way of expressing irrational numbers is a non-perfect square. So square root of 20, square root of 50, square root of 37. If you were to punch this into your calculator, you would get a really, really long decimal, and it would go on forever and it wouldn't end. So non-perfect squares are irrational numbers like the ones shown here. They could also be written in the form of a non-perfect cube. So the cube root of 45, cube root of 60, cube root of 57. If you were to punch these into your calculator, you would get the same result as punching these into your calculator. You would just get a never-ending decimal. Rational numbers are comprised of natural numbers, whole numbers, and integers, as well as those decimal numbers that either end or repeat. Rational numbers and irrational numbers are part of the real numbers. Here is another way of organizing the different types of numbers. So we have natural numbers, which are included in whole numbers, which are part of integers, which are part of rational numbers, and then irrational numbers is just its own category, and then all of these are part of the real number system. Thanks for watching, guys. I'll see you soon.